This is Geometry Lesson 2.5. We're going to be talking about special relationships between pairs of angles, and we're going to be writing conjectures for those angles. So in this lesson, we're going to be talking about what's called a linear pair of angles. And we've already talked about what they are. So a linear pair, remember, would be where they share a vertex and a common side, and their non-common sides form a line. For example, angles 1 and 4 would be a linear pair of angles, where they share this common side, they share a vertex, and then their non-common sides form this straight line. On this linear pair conjecture, it just simply means that they add up to 180 degrees. So angle 1 plus angle 4 equals 180 degrees. So the linear pair of angles conjecture states that they are supplementary. Now another linear pair off of this picture would be 1 and 2. Another pair would be 3 and 2. And the last pair would be 3 and 4. So anytime you can find that straight line and make a semicircle, that's going to be a linear pair, and they will be supplementary. They will add up to 180. The next one is the vertical angles conjecture, and we already know what vertical angles are. We've talked about those, where they share a vertex, but they do not share a side. They are formed by two intersecting lines. So angle 1 and angle 3 would be a pair of vertical angles, and 2 and 4 would be a pair of vertical angles. And for vertical angles, they're actually congruent in size. So 2 and 4 are congruent, and 1 and 3 are congruent. They are congruent. So angle 1 is congruent to angle 3. Angle 4 is congruent to angle 2. And remember the hash marks, doesn't matter how many marks you have as long as they're the same for congruent angles. So here we have an angle chase, and we're going to use those two conjectures, the vertical angles and linear pair, to solve for all the missing angle measurements. So based off of, let's just start with alphabetically. So we have this angle A here, and next to it is a linear pair with 35. And so A and 35, to make that semicircle, they have to add up to 180. So you just take your calculator and take 180, write it out here, minus 35, and you're going to get 145 degrees for angle A. Now because 35 is a vertical pair with B, they're across from each other where they have that same vertex, B would be congruent to 35. So B is 35 degrees, and if you notice, the 35 and the 145, they are supplementary because they are a linear pair. And then A and C are vertical angles, so C would also be 145 degrees. If we move over to the next group, in alphabetical order here, I don't exactly have any measurements, so I can't really do much. However, if I look on the inside here, I notice that I have a triangle. And triangles have to add up to 180 degrees. And so I'll use that information to find D, and then I can find E, F, and G. So I'm going to take the 50 and the 35 and add those together. So that would get me 85. And then subtract that from the triangle, and that would get me 95 degrees left over. Now I realize that the triangle itself does not look like that should be 95 degrees. Don't ever go based off of looks. When I make these myself, I just do a quick triangle, whatever's available. The book sometimes will try to throw you off based on looks. So always go off of measurements and specific markings. Okay, now that we have D, F would be a vertical angle, so that would be congruent, 95 degrees. And G and F, or D and G, those are a linear pair. So to make a total of 180, these would have to be 85 and 95. And then vertical angles would be the same. Then we can move up here to I, J, and H. Vertical angles are the same, so J would be 50. The linear pair, like example these two, would have to add up to 180. So if I just take 180 minus the 50, get 130 left over for I and for H, because this would also be a linear pair or their vertical angles. Okay, this statement here, we're going to be talking about true and false statements and then the converse of a statement. So this statement, if it is raining, then there is at least one cloud. And in order to create precipitation, you do need to have some sort of cloud formation. So I would say that this statement is true. You do need to have at least one tiny little cloud formation to make some sort of raindrop or, I guess, precipitation happen. When you turn around an if-then statement, so notice I have an if and then I have the parts underlined. If you reverse it, it's called the converse. So if I was going to reverse these two, my statement would be, if there is at least one cloud, then it is raining. And if I think about that statement, just because it's a cloudy day doesn't necessarily mean it's raining. So this statement is actually false. And a converse could still be true or could be false. It doesn't necessarily have to do with this answer up here. Both statements could be true, both statements could be false. And that's it for the lesson. So this is our practice regarding vertical angles, linear pairs of angles, and then the converses of statements.